Okay, on page 245, you're given the graph of sine and cosine, and the sine graph got cut off a little bit. So it was, sorry, the cosine one. So this one is the sine graph, and down below is the cosine graph. And we're just going to fill in the table. It says, what's the domain? Well, this graph's going to keep going from side to side forever, so its domain is negative infinity to infinity. The range, up top up here, sine touches 1, and down here at the bottom it touches negative 1, so negative 1 to 1. My maximum value is 1. My minimum value is negative 1. My intercepts, if you look right here, I have one at 0, 0, and then another one at pi 0, another one at 2 pi 0. So every pi I have an intercept. So I'm going to write 0 plus or minus pi n. So you can go pi this way or pi the other direction, and every pi you're going to have an intercept. And then my amplitude. Amplitude means how high or how low do I go? Well, I go up 1 and I go down 1, so my amplitude is 1. And period means how long does it take for me to repeat myself? So if I start right here, it takes me until 2 pi to get back there. I can't say pi because I have to go up and down till I repeat. And so now that I've gone up and down, now I'm going to repeat again, up and down, so 2 pi. You'll notice in the cosine graph that a lot of this information is exactly the same. So if you look at your cosine graph and we fill this out, again the domain is going to be negative infinity to infinity. Again the graph goes from negative 1 to 1. Its maximum is 1, its minimum is negative 1, its intercepts are a little bit different. We'll talk about those in 1 second. Its amplitude is 1, and again its period is 2 pi. Okay, let's look at the cosine graph. The cosine graph's intercepts don't start at 0, they start at pi over 2. And then if you go pi units, you get another one. So instead of starting like we did here at 0, for our intercepts for the cosine graph, we're going to start at pi over 2 and do plus or minus pi n comma 0. So it says down below, what's the difference between the sine and the cosine graph? Oops, sorry. Well, if you look at these two graphs, they both look like waves that go up and down, and in fact, they're very similar, except they're a little bit off. And what I mean by that is that they're a phase shift off. One of them has been shifted and the other one hasn't, because sine starts at 0, but cosine up here starts at 1. And so they're a little bit apart. So if I were to take this dot right here, and I were to shift it over pi over 2 units, which I'm going to do in a color, I shift this dot over here to right here, and I shift this dot right here to over here, pi over 2 units, you can see the sine graph is starting to form. And if I shift this dot right here over to pi over 2 units to pi, you'll quickly see that this graph is a phase shift of pi over 2 apart. So that's what we're going to write down here. Sine and cosine are identical graphs, except they are one, we're going to use the right vocab word, phase shift of pi over 2 to the right apart. Okay, so let's talk about graphing these by hand. And so to do that, let's talk about where these graphs come from. So we're going to go piece by piece of an equation and talk about graphing. But before we do that, I'm going to go down here and I want to draw for you for a second. And I know that my drawing is not the best, but just bear with me. When we're on the unit circle, and we're talking about sine to start with, when we're at 0, this ordered pair right here is 0, oops, sorry, nope, let's fix that, 1, 0. And then up here, the ordered pair is 0, 1, and the ordered pair over here is negative 1, 0. The ordered pair over down here is 0, -1. Okay, so if you're talking about sine for a second, when you're right here at 0 degrees, sine, the y value is 0. So at 0 degrees or 0 radians, we're at 0. And then at pi over 2, we're at 1. And at pi, the y value over here is 0 again. And at 3 pi over 2, we're at -1. And when we get back around the circle to 2 pi, we're back at 0. So if I were to graph that, 0, pi over 2, pi, 3 pi over 2, 2 pi, 1, -1. If I were to graph this, 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, -1, 2 pi, 0. There's that exact curve that we were just talking about. And all I did was use the values around this unit circle. Same idea if I go over up here and do cosine for a second. Cosine of theta. Same angle, 0, pi over 2, pi, 3 pi over 2, and 2 pi, except for instead of using the y values around the circle, you're going to use the x values. So 1, 0, -1, 0, 1. And so again, actually let's graph it on the same graph. If I go down here and I graph it, at 0 I was at 1, pi over 2 you're at 0, pi you're at -1, 3 pi over 2 you're at 0, and at 2 pi you're back at 1 again. So there's your cosine graph. And that's where these points in the graphs come from. So let's go back to the top of the page. And first we're going to talk about amplitude. And so this letter out front, this little a, is the amplitude. It tells you how high or how low the graph goes. Or it represents half the distance between the maximum and the minimum values, which in other words is how high or how low it goes. So if a is a stretch, so if the absolute value of a is bigger than 1, it's a stretch. And when the absolute value of a is less than 1, it's a shrink. And if a is negative, the graph's gonna, like always, reflect across the x-axis. So we're not changing any of the rules of transformation. These are the same rules we've been using since the beginning of the year. However, we're just applying them to sine functions now, or cosine and trig functions in general. So it says here that we're going to graph 0.5 sine theta and 2 sine theta. So what I'm going to do is I'm going to go down here, I'm going to copy this graph that I wrote at the bottom, I'm going to copy it up here for a second. I'm going to leave some space and you'll see why in a second. So I'm going to write theta down, 0, pi over 2, pi, 3 pi over 2, and my 2 pi. Okay, and so then I'm going to write down y, because I'm talking about sine. So it was 0, 1, 0, -1, 0. And then I'm going to color code. So if I want to change my amplitude to 0.5, that means I'm going to multiply all these y values right here by 0.5. So I'm going to put a little orange star so we can color code. And I'm going to multiply by 0.5. So this is going to be 0, 0.5, 0, -0.5, and 0. So I'm going to graph that. I'm going to graph my orange y stuff and my theta stuff. So I'm going to go up to the graph. At 0, I'm at 0. At pi over 2, I'm at half. At pi, I'm at 0. At 3 pi over 2, I'm at -half. And at 2 pi, I'm back at 0. And you can go backwards and you realize that every pi over 2 unit, you progress up and down along with the pattern. So if you're at 0 and you go backwards, it should be -0.5, 0, 0.5, and then 0 again. So there's my sine graph. And then in my green, I'm going to do the exact same thing, Only instead of multiplying my y values by 0.5, I'm going to go back to my y values in this table right here, and I'm going to multiply them all by 2. So take these y values multiplied by 2, you get 0, 2, 0, negative 2, 0. So if I go back here and graph, this one stayed the same, but this one, instead of being at 0.5, is up at 2, and then 0, and then negative 2, and then 0. So this time I've pulled my graph vertically, and I've stretched it up and down so that it has an amplitude of 2. It goes up 2, down 2, up 2, down 2. And I can progress this pattern backwards. And get the rest of my sine graph. So go back to Edmodo, and there's going to be another video to help you with the rest of the pages.